All right, let's talk about one of the most fundamental pieces of digital electronics, the flip-flop.
Here's the thing. It's a component that so many students, maybe even you, get wrong. And it's all because they miss one tiny, crucial detail.
But don't worry, we're going to fix that right now. We're going to get to the real truth. You ready?
Okay, here it is. The single most important difference. Latches, they're level triggered. Think of it like a window. When the clock is high, the window is open and data just flows through. But flip-flops, oh, they're edge triggered. They only care about that split-second moment the clock signal changes. It's like a camera shutter taking a snapshot. That's it. That's the secret.
So why is that edge triggering so important? Well, to get that, we got to look at the problems, the flaws in the original building blocks.
So let's start with the granddaddy of them all, the SR latch. It's super simple. S is for set, it makes the output a 1. R is for reset, makes it a 0. Both are 0, it just holds on to whatever it had before. Piece of cake, right?
Well, not quite. There's a fatal flaw. What happens if you make both S and R equal to 1? You get the forbidden state. The output goes haywire. It's totally unpredictable. It's a huge no-no.
Okay, so then came the JK flip-flop to try and fix this. But guess what? It introduced its own problem, the race-around condition. See, if J, K, and the clock are all high at the same time, the output just starts flipping back and forth, over and over uncontrollably. By the time the clock goes low, who knows what state it'll land on? It's a total gamble.
And this is where the real-world solutions come in. These are the workhorses that engineers actually use today. First up, the D flip-flop. D just stands for data. It is the king of predictability. Whatever you put on the D input, that's what it captures and holds on the clock edge. Simple, reliable, no forbidden states, no mess. This is what you build things like shift registers out of.
So, what about that pesky race-around problem? That gets solved by something brilliant, the master-slave JK flip-flop. It's a two-stage process. The master part grabs the input on one edge of the clock, and then the slave part spits it out on the other edge. That two-step dance completely stops the uncontrolled toggling. Problem solved.
So let's recap the journey, right? You had the SR latch with its forbidden state, then the JK flip-flop with its crazy race-around condition, and finally the D flip-flop, and the master-slave design came in as the heroes to give us the stable, predictable logic we absolutely need.
And here's the bottom line. If you really get this story, this evolution from flawed ideas to smart solutions, then things like counters and registers, they suddenly become so much easier. It all just clicks. Everything starts right here.